All right, what's up, guys? My name's Javi. Welcome to the third review preview session for ENGI 1331. Today we'll be reviewing user-defined functions and previewing logical statements and arrays. We'll also be introducing some new functions all throughout the video. So this is going to be a pretty informational video for you guys. So we're going to begin with the review of user-defined functions. So like I said last time, user-defined functions are no more than functions that we write ourselves, meaning that they are blocks of code that we write to perform a specific task or set of tasks every time we call them. So for example, I have this function I wrote that calculates the magnitude of a vector in 3 space. I have a function here that calculates the 2 roots of a second degree polynomial with the inputs of its 3 coefficients. Or it could be something as simple as just outputting a fprintf to the command window. So notice the common syntax for every example function I just showed you guys. Every function starts with the keyword function. Every function has some output. Every function has a name, find mag, root poly2, statement ma2, and some inputs. So v, abc, and even more in this case. So we can have either a set of inputs, as shown here and here, or a single input, and we can have a single output or a set of outputs. So every function has an input. It does some arbitrary task with that input, and then defines an output inside of it. Here and here, A is here. And of course, they're always capped with an end statement. So basically, the whole point of user-defined functions is to get around writing code over and over and over again that does the same thing. When we want to be able to call these functions to do certain things for us so we don't have to keep writing things over and over. So for example, if I wanted to calculate the magnitude of these 4 vectors, without user-defined functions, I would have to copy this line right here and define a variable for each one. So in this case, it'd be v1, right, since we're taking the magnitude of v1. In this case, mag2, v2, 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 but that gets pretty tedious. So instead, we can say mag1 becomes find mag and input v1 as our input vector. And in this case, and so on. So basically, every time we call this find mag function, we're assigning the value of whatever vector we input to v. So basically what we're saying is v becomes v1. But since v1 is defined in this script and not in this script, we can't use this. That's why we have to say it's an input to our function, because we're taking it from one script and bringing that value over here. So some other stuff I'd like to point out about user-defined functions. So for example, in statement ma2, what we're trying to do is say some amount in grams of some material releases some amount of joules of heat during some amount of Kelvin temperature change, which requires some amount of gallons of liquid. And we have these variables right here in our fprintf. And they're inputs to our function. If I call this function and input these values as our inputs, we don't get an error. We get everything substituted in the right place. So the point I'm making here is that these variable names don't have to match up with whatever we input here. So they don't have to, the names don't have to agree. But we do recommend the names agree for you guys because it makes it a little easier to kind of understand what you're doing with your code, at least for you guys. The only problem you can run into with this is if the variable names are not in the right order. So if we had material name and mass inputted in a different order, so say material name was first. Okay, so we run this. Not a number, grams of 5 times 10 to the negative 1. So we didn't get the right output, right? The reason for that is because we assigned mmat, which was supposed to be the mass, with the string copper. And so whenever we put it in our fprintf, we put mmat first, and we have a %0.2f, which stands for a number being in that place. So we have to be careful with the order that we input these inputs as. Another point I'd like to make is that user-defined functions only know what's inputted and what's inside of them. So for example, if I try to say fprintf, the code was ran some amount of times, and I have number of times here. And I define number of times to be 3 in this. And I run this. Undefined function variable number of times. There's an error in our function, which causes an error in our script that called it. The error in our function was that number of times was not defined. So functions, like I said, they only know what's defined or inputted to them. So if we add number of times, and we say num here, you run this. It's ran 3 times, right? Because we added it to it, and it becomes an input. This also goes the same way for our script that's calling the function. So if we were to find x to be 34, and we don't output it, we put x here. Our script doesn't know what x is because we defined it in our function, and we didn't output it. Some last few points I'd like to make about this is that functions must always be saved under the same name as they have in their script. So when I save this file right here, I named it statement ma2. I click save as. It has to be named the same thing as it's named in the editor, or it won't run. Another point I'd like to make is that these function scripts must always be located inside the same current folder as the script that's calling it. So as you can see from my current folder window, statement ma2.m is in the same folder as session 3. And also a big note, because everybody does this on the first MA, always include these function scripts in your zip folder when you turn in your MA. Because if we try to run your MA and you had to define a user-defined function, and we try to run this, and if I didn't have the function statement ma2, which was required for ma2, your code won't run because my computer will not know what that function is unless I have this function script. So please include your function scripts inside of your zip submission. So the next segment I'd like to get into is conditional statements and logical arrays. So this next part of the session will be all preview, some stuff you guys haven't seen. So a conditional statement is basically just a line of code that runs a block of code so long as that certain condition is met. So today we'll be only covering if statements, which is the most basic kind of conditional statement. So the 2 main uses of if statements you'll see in this class are to separate our code into 2 entirely different parts that do 2 entirely different things, or they can also be used as checks for user input. So let's go ahead and write out a basic if statement. Let's say we want the user to enter 2 numbers, and we always want the second number to be greater than the first. If not, I want to either throw an error or a warning, and I'll show you guys how to do that as well. So to check if the user entered this number, or the second number that greater than the first, we can use an if statement. All if statements start with the keyword if, and they have some condition. So that's our condition. If we want our code to stop if the second number is not greater than the first, we say if u2 is less than u1, we want an error. We want our code to stop, right? So to cause an error in your code, you can use the error function. So if we type an error, open the parentheses, it asks for a message. So what we're saying right here is if the second number the user entered is less than the first number the user entered, I want an error. So I run this, enter a number, 45, and I enter a number greater than that, 90. We don't get an error. Our code finishes. Run it again, 34, 2, which is less than 34. We get the error we actually wanted, what we typed up here. So The error function, as you can see, stops our code. So if I were to type in fprintf down here, were to run this again, and I say 3, we don't get to that fprintf because the error stopped our code, because this condition was met. If we enter a number greater than it, this condition is no longer met, so we skip everything inside the if and move on to the fprintf. So as you can see, the error stops our code completely. We can also use the warning function. And the warning function prints out a warning. But the warning doesn't stop our code. So as you can see, the condition was met. 2 is less than 45. We printed out a warning. We finished the if statement, and then we printed out hey, because the warning doesn't stop our code. So as you can see, I did use 2 different symbols. So before I used the greater than symbol, and here I used the less than symbol. There's a bunch of different symbols we can use. We can use, like I said, greater than. We can use less than. We can use greater than or equal to. We can use less than or equal to. We can use equal to. And note how equal to is a double equal sign and not a single. The reason for that is because we use the single to define variables. The double equal sign is a comparison of equality. And there's also not equal to, which is this squiggle in front of the equal sign. So if u1 is not equal to 0, we run this. We can also have multiple conditions inside of these if statements. The first, I guess, combination operator I'd like to use is the double ampersand, which is defined by this. And it means that both conditions have to be true for whatever is inside the if statement to run. So let's have an example. Let's say enter a number less than 30. And we're going to assume the user actually enters a number less than 30. And the second number, we want to be greater than the last and less than 100. U2 is greater than U1 and U2 is less than 100. Then let's say, if I run this, enter a number less than 30, let's assume the user actually does it. Enter a second number greater than the first and less than 100. So if I enter a number greater than 29, which is 30, which is also less than 100, we get a great job. If I run this again, enter a number less than 30, let's assume the user does this correctly, 25. Enter a second number greater than the first and less than 100. So I enter 101. It's greater than 25, but it's not less than 100. I don't get the great job because this condition was not met. So if we run this again, 25. So greater than the first and less than 100. So let's say 24. It's not greater than the first. So this condition would not be met. And we don't get the great job. So the double ampersand basically means that both conditions have to be met for whatever's inside the if to run. We can also add multiple. So we get another one over here, and another one over here, and so on. Next combination operator I'd like to go over is the OR, which is defined by these 2 characters right here. It's usually above the enter key, and you'd have to hold shift to put both of them. The OR basically means only one condition has to be met for the code to be run. So for example, is less than U1 or U2 is greater than 100, we want a great job because the user did it right. So if we run this, let's say 50, enter a second number less than the first or greater than 100. So if we say 56, we don't get the great job because this is neither less than the first or greater than 100. But if we say 50 again, 45, we get the great job because only one of the conditions has to be met when we're using the OR operator. And the same thing works for this. But we can also have multiple if statements inside of one if. Let's say we want to make a code that determines what TV or movie our user wants to watch. So if TV or movie equals 1, meaning we chose the first option, which is TV. We want a menu to pop up so we can use the else if to basically define another condition. So TV or movie equals 2, meaning we chose to watch a movie. So now if let me comment all this out real quick so we don't have any extra variables except for our housekeeping commands. You get a menu. Do you want to watch a TV or a movie? And we say TV. Because we picked the first index, TV or movie equaled 1, and so we got the menu that asks what TV show they want to watch. So it says Office. Then our code finishes. So again, do you want to watch TV or movie? Pick movie, meaning we chose the second one. TV or movie equals 2. We get the movie menu. So if we were to ask this again, quick run, we run through this right here first. Do you want to watch TV or movie? If I pick TV, what show would you like to watch? Right here. I click The Office. Since I have this in here again, it's going to ask me again. If I were to pick movie, we don't get this menu here. And the reason for that is once the code runs into this if, it then decides which condition is met. So if you try to redefine that condition again, it's not going to work if it's already inside the if. We can also nest these if statements. And by that, I mean we can put if statements inside of if statements. 4 different genres. If genre equals 1, meaning we chose action, we could ask for that same menu again. We could call for another if. We say if TV or movie equals 1. We could then put that same stuff in here. Else if TV or movie and so now you see how I ended this if statement right here? This one is still open. So now I type else if again. This else if is linked to this if. So now we bounce out to the genre again. We could basically just copy and paste this in here, except we would just change up our options. And so now we see we've ended this if statement right here, which is inside of this if statement. Now let's go ahead and include an else. And so what an else is, it executes whatever's inside the else if none of these two conditions were met, because this else is linked to here. You can tell by the tab. This if is linked to this else if and this end. This else if is linked to this if and this else. So we didn't have anything in that genre. What genre would you like to watch? If I pick action, meaning genre is equal to 1, I chose the first one, I should get the menu. Do you want to watch a TV show or movie? So we got genre equal to 1 because I picked action. We move into here, or right here. Let's say TV. So TV or movie equals 1 since we picked TV. So then it asks this question. And then we finish our code. Because after it asks this question, since TV or movie equaled 1, we already defined it before this if. We move into this if, asking if it's 1 or 2. It runs this. Since we didn't define it again, we can't define it again. It finishes this with this end. Since we can't define genre again, it bounces out to this end. So we say funny, genre equals 2 now. Would you like to watch a TV show or movie? Let's say movie this time. So instead of bouncing out to TV or movie equals 1, asking for a TV show, We bounce out to the else if over here. We ask for the movie. So you can see that whenever we define TV or movie, and then we hit the if that asks if TV movie is 1 or 2, this else if is always linked to this if. So if this was not met, it moves to this condition, which is exactly what happened here since we picked movie. So any South Park movie. And then we're done. Because again, we can't redefine TV or movie. We can't redefine genre because we already said it was 2. So it bounces out to this end. So if we say kids, genre was 4, we don't have an if or else if for genre to be 4, meaning these 2 conditions were not met. We bounce out to the else, which is run only when no conditions were met, and we fprintf out, we don't have any in that genre. So let's say our user closes out of the menu. 0. I want an error. So what we're saying here is if genre was 0, I want an error to pop up saying the user didn't pick anything. So if I run this, how do you guys think we're going to get 0? We hit the X. If we hit the X, that means nothing was selected. 1 through 4 was not selected. Error, you didn't pick anything because genre was a 0 because we exited out of the menu. So menu always runs like that, but this is going to be helpful. Like I said earlier, we're going to be using if statements to validate user input. So if I have a menu and the user input doesn't pick, if the user doesn't pick anything, then I want my code to stop and tell them, hey, you didn't pick anything. So next, we're going to go ahead and move into logical arrays. So logical arrays are basically arrays of true and false values. And remember how in the first video I said true always corresponds to the value of 1 and false always corresponds to the value of 0. A holds not the word true, but 1, and B holds not the word false, but 0. Let's go ahead and create a logical array. So before we do that, let's go ahead and create a matrix, call it mat1, and we're going to use a function that maybe you guys haven't used before. It's called the randi function. What it stands for is random integer. And so when we open the parentheses, we see it calls for an Imax. Imax is the number, the maximum number we want our integers to be up to. So if we're creating a matrix, we also see this n and this size 1 through size n. We can, again, just like ones and zeros, the 2 functions, ones and zeros, we can define the size of this matrix. So let's say I want a matrix that has integer values up to the value of 100, and I want it to be a 10 by 10. Mat1 is a 10 by 10 that stores values anywhere from 0 to 100. So if randi automatically assumes that we want positive values, so it goes from 0 to whatever maximum number is right here. We can also define a range. So if we want to have positive values, we could say -5 through 10, a 10 by 10. Run this again, and see we have values again that are through -5 and 10. I'm going to stick with 100 for now. Like I said, we can also define the number of rows and the number of columns specifically. So we always want to define the rows first. So let's say we want a 3-row by 2 column. 3-row by 2 column. And these are always random integers. So if I do this again, they're different values every time. Every time I run this, the values change. That's what the randi function is for. I still want a 10 by 10. Stick with that. Run this. So let's create a logical array. Let's go ahead and say, let's name it logi, becomes where mat1 is greater than 20. Okay, that's what we're basically saying right there. We're saying logi is where mat1 is greater than 20. So if we run this, we see logi is still a 10 by 10, the same size as mat1. But if we go into this, it's full of a bunch of ones and zeros. So basically, the ones correspond to where this condition right here was met. So 39 is greater than 20, stores a 1. 3 is not greater than 20, so it stores a 0, and so on. These logical arrays will mostly be used for indices. So let's say mat2 becomes mat1 at logi. So we're using a matrix to index a matrix, right? That doesn't seem right, but since it's a logical array, it works a little different than normal indexing. So if we run this, mat2 is an 83 by 1. So if we go into mat1, we see the first value at 1, 1 is 63. We store 1 there. The first value mat2 is 63. So as you can see, since MATLAB counts down column to column, we'll see that the next value stored should be 40. It's 40. So what it did is it took out every value that met this condition, in this case greater than 20, and stored them in mat2, the actual values themselves, not the location. It's important to note. So we can change these up any way we want, greater than or equal to 20. It'll still run. So we can still use those same symbols. And of course, these symbols are going to be noted on your function sheet. So again, I put an example of some syntax for an if statement. I'm going to update this as well. So the next section I'd like to get into is the use of the find function. The reason I want to introduce this function is because its input is actually a conditional statement. So the purpose of the find function is it finds the location of where a certain condition is met. So last time, or in the last section, we discussed the logical array, which helped us index at the values where this condition was met. And it gave us the values that met the condition. But with the find function, we can then get the location of where these values occurred. So we're going to use mat1 again. Let's say loc becomes find, open the parentheses, where mat1 is greater than 20. Let's change this as well. So if we close this, and we run it, loc is a 72 by 1 double. 1, 3, 5, 6, 7. So these numbers are obviously not greater than 20, so it's not storing the value. Again, remember that MATLAB counts downwards like this, column to column. So this is numbers 1 through 10. This is 11, 12, 13, 14, 15, and so on. So we asked to find where it's greater than 20. Position 1. Yep. Next should be 3. Next should be 5. 6, 7, and 8 also. 10, not 9. 6, 7, 8, 10, and 11. And then it doesn't meet the condition again until 16. So 12, 13, 14, 15, 16. That's greater than 20. So we can use this comparison right here. We could also say where it equals, let's say where it equals 20. Let's see if we have any. We get lucky. Yeah, so loc is 64 and 95. So index, when counting like this, of 64, so this is 60, 1, 2, 3, 4, 20. So as you saw, I only used one variable here, loc, but we can also use two variables here, just like we did for size. And so let's say where it's greater than 20 again, because we'll get more values, and we run this. So if you look at mat1, the first time where it's greater than 20 is at position 1, 1. 1, 1. So what we're doing here is every time we find a value greater than 20, we're storing the row and the column. So the next one, it's still counting like this. The next one is row 2, column 1. Row 2, column 1. Then row 4, column 1, and so on. So on MA2, you guys had something along the lines of these were different days and these were different outposts, right? So we could find the value. So say we wanted to find a specific value. Say we wanted to find where the ice thickness was 83 inches. We'd say where it equals 83. Let's go ahead and comment this out because I did see one occurrence of 83. Make sure we don't clear this out. We run this. R loc and C loc are three different values. Go to mat1. R loc, the first occurrence is row 6, column 5. Row 6, column 5, 83. Next occurrence is row 1, column 8. Row 1, column 8, 83. And so on. Next occurrence, row 5, column 8, row 5, column 8. The main difference between the two, don't get it confused with logical arrays. Logical array gives us the actual values when we use it as an index. The find function gives us the position of where the condition occurred. We can also use a logical array to see how many times our data was greater than 20. So again, these are different days. These are different outposts. We want to see how many times it was greater, the ice thickness was greater than, I don't know, 30. We could just say the sum of logi, comma all. Because we're taking it with the sum with respect to the entire matrix. So we're taking the sum of all the cells. By taking the sum of logi, we're taking the sum of ones and zeros. The 1 corresponds to where the condition was met. The 0 corresponds to where the condition was not met. So when we're taking the sum, we're adding all these ones together. We're basically seeing how many times the ice had a thickness greater than, let's say, 50. Thick ice. So there are 52 different combinations of days and outposts that had an ice thickness greater than 50.
Okay. So you hear me?
Yeah, I hear you.
Okay, sure. So you grade something like menu 1 equal to the whole vector, and you grade one menu when you user choose the first value for saying like apple, then you're gonna output the index of that maybe like 1, and then when the user selecting a second menu saying between like car, train, plane, and then you choosing car, so can you recycle the first variable?
Oh,
Or
so you say menu 1 becomes one thing, and then you try to use menu 1 as another.
again, yeah.
Okay.
Would that override the previous value, or it gonna?
You can, but I wouldn't recommend it, because later in the course we're going to be using while loops, and what while loops do is they basically repeat everything that's inside of them. So if you were to say define a variable as something and then define a variable as something, the same variable as something else, and you were to run that while loop again, you may run into a problem because you redefined the variable. Either way, I would definitely recommend to not do that, just out of good habit. So Eugene asks, can you also elaborate on the user error, say error? Okay, so let's say we have a number greater than 100. We put an if statement here. If U1 is less than or equal to 100, meaning it's not greater than 100, we put an error here. We call the error function. So here we'd put the number entered is not greater than 100. We run this, 20. It's not greater than 100. We get an error. So the only reason you'd be using the error function is if we explicitly tell you in your MA, if the user does this, make your code throw an error saying this. So you want to see that you can use the error function, because the whole point about the error function is it's an error that we made on purpose because the user did something wrong. So it's not an error because our code didn't work, it's an error because the user was at fault. And so with warning, your MA will maybe ask you, instead of to throw an error, to throw a warning at the user. And so the reason we use a warning instead of an error is, again, because it doesn't end our code. And we could say U1 becomes 101. The number entered was not greater than 100, assuming 101, the first integer after 100. So if I enter 20, warning, the number entered was not greater than 100, assuming 101. And it assigns U1 to 101. That would be, again, the case if we tell you to explicitly use a warning and then assign the value to be something else, because we don't want your code to error there.